Okay, guys, it's September 24th. We're finishing up 4.1. We'll get into 4.2, 7.1, and 5.2 if time warrants. Okay. All right, so find the slope of line A parallel and B perpendicular to the line negative 4x plus y equals negative 7. So they want the slope for a line that's parallel to this and then one that's perpendicular. Well, first off, what we have to do is we have to turn around and we have to go y equals 4x minus 7. Are you okay with where I got y equals 4x minus 7? I took this negative 4x over to the other side, right? You with me? All right, now, so that means the slope is 4 over 1. Y'all agree? So if you're going to have lines that are parallel, then slopes are the same. Good. So the slope for the parallel line would be 4, right? And the slope for the perpendicular would be the opposite or negative reciprocal, right? So this is a positive. That would be a negative, and that's 4 over 1, which switches to 1 over what? That's right, negative 1 over 4. Any questions? Yes.
Can you repeat that? You said the perpendicular is the reciprocal. Okay,
yes, negative reciprocal. Sometimes people say opposite. Okay. So if you got one positive, you definitely have to have one negative, right? That's how you get your crisscross. And then it being the reciprocal ensures that it's going to intersect and be 90 degrees. Okay. That's the so it's two-parter right there. All right. So determine whether these lines below are parallel, neither are perpendicular. So first things first. Easiest thing is just to put all of them in what? What would we put all these lines in? Slope-intercept form. Thank you. So I got 4y plus 3x equals 12. So minus 3x. All right, so I got y equals negative 3/4 x plus 3 for the top one. We'll have negative 12y equals 9x plus 8. And we'll divide everything by negative 12. That leaves me in y equals, that is negative 3/4 x, and that is negative 2/3. Now, there's your slopes. They are what? They're what? The same, which means that those are parallel. Okay? Any questions on that? So it's just basically manipulating the equations. Okay. All right. Y'all good? Yeah. Okay, so write an equation for the line parallel to negative 5x plus 3 and passing through the point 4, negative 21. All right, guys. I'm going to tell you something. We're going to write this, and we're going to use the equation point slope form, okay? So the slope for this one is negative 5, right? If they're parallel, then this slope is the same as that slope of that line, right? So this one would be negative 5, right? So we have a point and a slope. Y'all agree? So we have y minus y1 equals m times x minus x1. So when you plug these things in, you got to make sure that your coordinates change signs. And the reason why they change signs is this. We have y minus y1 coordinate equals x m, the slope times x minus the x1 coordinate, right? So when you're minusing something, it changes sign. So y, that's a negative 21, so it's a positive 21. Slope is negative 5. It doesn't change. X, and that's a 4. Now it becomes a negative 4. All we're going to do is distribute. Bring down the y plus 21 equals negative 5x plus 20 minus 21. Y equals negative 5x minus 1. So that would be the equation for the line that is parallel to the negative 5x plus 3, but passes through 4, negative 21, right? Point slope. Yeah, because it takes a point and a slope. And that's primarily its only purpose. You don't use it a lot, but it is super easy. I like it better than trying to do this. Negative 21 equals negative 5 times 4 plus b. You know the traditional find the b, right? Now you got to write the equation. Y'all remember this? You got to do that. You got to plug that stuff in. You got to plug x and y in a slope. Why not just plug it into the slope, the point slope formula? And when you're done, guess what? You have the whole equation in slope intercept form, right? I like that a lot better. And that's its whole purpose. Okay? All right. So this one is, we will write it, that is perpendicular, right? So let's kind of look back here. So M1 is negative 4 over 1, right? When you're looking at fractions or slope, you need to write them as a fraction if you're going to do something with them, like a parallel or perpendicular. Now, I'm going to call this M2, right? So the relationship between line 1 and line 2 is that they are what? Perpendicular, which means it has to be opposite or negative reciprocal. So if I got a negative here, it'll be a positive over there, right? I got 4 over 1, which would become 1/4 here. Any questions? All right, then I'm right back in the same thing. Y minus y1 equals m times x minus x1. You automatically get your slope right there, but that would be plus 1, y minus 4. And then, of course, let's just add 4 to both sides. There you go. So y equals 1/4 x plus 5. Any questions on that?
On your second M2, your slope on where you got the 1/4, that came from,
Knowing that they're perpendicular.
so you took that -4 and just made it positive.
That's right. I know that the relationship between perpendicular slopes are negative reciprocals or opposite reciprocals because the product of them better equal -1. And the only way that that is, if I took -4 over 1 times 1 over 4, that's -4 over 4, which is -1. And that's what it has to be in order for it to be perpendicular. That's the theory behind it. That's why if one's positive, the other has to be negative, and then it reciprocal ensures that you'll have the 1 over 1 when you get done simplifying.
And when you multiply them together, you have to get
A -1.
-1.
Yeah. That's the theory behind that's what proves that these are perpendicular, right? So, but normally if you just have -4/1, you know that that's negative, then the other one better be positive. If it's 4/1, just flip it. Just flip your fraction. That's what a reciprocal does. Just top goes bottom, bottom goes to top. Yeah. Okay. All right. That's it on 4/1, right? Yes? Okay, good. And that. So I want 4/2. There. All right. So we're going to look at modeling with linear functions, okay? Um, you're going to identify inputs and outputs. All of these equations should be linear. You got to make sure you understand that, because that's going to help you go, because some of these things will make you go, think other types of functions, and you don't need to. Okay, so you got to understand that if a word problem gives you two sets of inputs and two sets of outputs, those things are ordered pairs, right? So you can find slope and then write the equation from there. If they give you inputs and outputs and just kind of in the beginning type things, those are y-intercepts in the beginning. So we'll just kind of get started and see where we end up at. This homework is like 10 questions, right? I don't know. I pulled a good bit of them, so to give you a little bit of help. The value of a forklift. Elliot buys a new forklift for his business. It will cost $140,000 and will decrease in value each year. The graph below shows the value of the forklift after the first 6 years of ownership. Okay. How much is the forklift worth after 6 years? Well, if we're looking at this, it has to be what? 20,000, but it really should be less than what? 20, right? Y'all agree? Do you understand why it should be less than? Well, it keeps decreasing, but look at it. At 6 years, it's at what? 20, right? So after 6 years, then that would mean that it would be below that, right? So not a well-written question, but just kind of keep that in mind. After how many years is the forklift worth $80,000? Well, that's an output, right? So go over here, go to 80,000, hit it there, come down, and that's what? 3. Find the slope of this line. So what we're going to do is we're just going to pick 2 points that are, well, they'll be perfectly on there, right? Doesn't matter which 2. I like smaller numbers, so can we pick these? All right, so if I pick those, then it's kind of look, well, I'm going to do this down and like that, right? So it's going from 60 down to 40. That's the change of how much? 20,000, right? 20K. And then X is what? So negative 20,000, right? Y'all see how I've done that? Okay. How far did it go in the Y's over how far it went in the X's? And it's negative because it's decreasing, correct? So, by how many dollars per year is the forklift decreasing in value? The forklift is decreasing by what? 20,000 per year, right? I wonder if that's true. Forklifts take a big hit like that? I have to ask my friends at. Well, you think about it. Think about how big the batteries are and everything else that goes on that. They're not cheap. I'll tell you what I'll do. I'll check with my friend. I got a friend that does rental stuff. Uh, I got a friend. um, what's the rental place off of Chase? Right there, corner of Chase and Newton Bridge. United. It used to be Neff. So I got a friend that works for Neff that now works for United. So I'll ask, see if that's about realistic. Or you could always Google it, right?
It says it's been anywhere from 15 to 100 plus on a new forklift.
Okay.
Well, Mercedes, depreciation is way worse.
All right. Find the equation of the line where V is the value after t years. Well, we've got the slope, right? What do we need? So if we're going to write the equation, we need two things. We need the slope and the what? So we know that slope is negative 20,000. What's the y-intercept, guys? That's right, 140,000. So that'd be y equals negative 20,000 x plus 140, right? There you go. Y'all remember that? Right here. The y-intercept is where it touches or crosses the y-axis, right? And all of these word problems should be taken in or happening within the first quadrant. So if they're happening within the first quadrant, then that far left is the y-axis. So that's why we say crosses or touches for such instances as this. All right, so okay. V equals negative 20,000 T plus 140, right? Because they're going to nail you on that. We could V of T. I don't think so. It should just be V. Yeah. They would have told you, bless you. That would exactly be correct. The value with respect to time, yes, sir. Yeah, yeah, you're correct. But their representation that they want is just a variable equal to, yeah. All right. Yay. In 2004, a school's population was 946. 2008, that population had grown to 1598. Assume that the population is changing linearly, which means, hey guys, it's going at a constant rate of change. How much did the population grow between 2004 and 2008? How much? Well, that'd be 1598 minus who? 946, right? That'd be 652. So that's 1598 minus 946. So it changed to 652 people, right? And that's 4 years. So if you do that, it's roughly about 150, 160, right? Yeah, roughly, rough averaging. How long did it take for the population to grow from 946 to 1598? 4 years. What are they pulling here? Our change in X and our change in what? Our Y. What is the average population growth per year? Well, folks, that would be what? 652 divided by 4, which is what? 163 people every year, right? Per year. 163 students per year. It's not bad. All right, what was the population in in year 2000? Huh? You could take 163 times what? Times 4, right? And then, what was it? 946 minus this number. So what does that give me? What? 600. Okay. All right. Excuse me. 652 students. So 946 minus 652. I got 294. 652. Is that okay? Yeah, y'all agree? Sweet. Find an equation for the population P of the school T years after 2000. So, folks, why did they have us find 2000? No. Read that question. Find an equation for the population of the school T years after 2000. Ladies and gentlemen, what was the population in 2000? That would be the y-intercept, would it not? That's exactly why they made us do that. So all they're doing is finding the change in x, change in y, the slope, and then finding the y-intercept. So that is a p sub t equals what? 163 t, right? Plus what? 294. So using your equation, predict the population of the school in 2011. Well, you can't just put 2011 in there. What do you put in there? What do you put in this equation, guys? That's exactly right. It'd be 163 times 11 plus 294. And let's pop it in a calculator. Huh? 2,087 students. How about that? Now, be curious. Anybody know when they start looking at building new schools? Anybody know? When you have reached 80% capacity, that's when they start planning for new schools. 102%? No, that'd be a little too late. But they start looking at it at 80% capacity. Yeah. So, sir? College student earns $30 per day delivering advertising brochures door to door, plus 25 cents for each person he interviews. How many people did he interview on a day when he earned $39? Well, normally you would say, hey, y equals what? He gets paid $30 flat, right? Plus 0.25 per person, right? Well, if that joker earned $39, because that's an output, right? So that's 9 divided by 0.25. That joker's going to go up because that's big one divided by a smaller one. So that's 36 what? 36 people, right? Fair enough? Yeah, okay. Just remember when you're doing these that, and I didn't pull every one of them. I just pulled some that I thought, okay. Just note that they're linear. Okay. The restaurant has fixed costs of $141 per day and average unit cost of $3.50 for each meal served. If a typical meal costs $5, how many customers must eat at the restaurant each day for the owner to break even? Okay. Now this one's not as hard as what you think it is, because you got to think about this. It costs $3.50 for the meal, and he sells it for what? $5. So really, how much is he making on every meal? $1.50 per meal, right? Right. Minus who? 140, right? Oh, snap. Sorry. How many customers must eat at the restaurant for the break even? What does that mean, break even? covers his costs. He's covered the cost to keep the lights on and to be able to say, hey, he's got a business. So profit's zero, right? So if I take this, move it over to the other side, I get 1.5x equals to 141. And if I take and divide both sides, ladies and gentlemen, by 1.5, 41 divided by 1.5 is 94 what? Customers, right? 94 customers. Does everybody understand where I got the 1.5? That's 5 minus 3.5 equals 1.5. I wish I had a better explanation than that, but that's all we got. Y'all good?
It's just a profit.
Yeah, yeah. Because you got how much you sell it for, how much it costs, the profit he's getting out of it, minus your overhead, right? Profit times how much? Yeah. So, all right. So that's 4-2 done, right? It's fast, fast. Okay, 4-2 done. Hey, 5-1. We'll be here for a little bit. Yeah. Huh? Yeah, I don't know. Okay. The general form of quadratic is ax squared plus bx plus c. I know they call it general form, and then they call standard form a times x minus h squared plus k. We really normally call this vertex form. And guys, as long as I can ever remember, we've always called this what? Right? Standard form of quadratics ax squared plus bx plus c. But I understand it is a general form, right? That is technically the general form, basically because of the conic section, right? When you talk about parabolas and all that. So, but the vertex form is really what we call the second equation. Is everybody with me on that? So you're going to be able to take a quadratic and you're going to be able to find the vertex of it, and you're going to be able to tell whether it opens up or opens down, and what the axis of symmetry is, and so forth. So if you had one of those handy-dandy TI-36X Pros calculators, you could type that thing in under the PolySolve, and it will give you where it crosses the x-axis, both points, and then you keep arrowing down, and it will go and give it to you in vertex form as well. So it's a rather useful calculator. So it says where a and b and c are real numbers and a can't be equal to 0, the coefficient of the quadratic term can't be equal to 0, because if it is, it's no longer a quadratic term. That disappears. Then it becomes linear, and we do not want that. All right, so here's important formulas that you got to make sure you understand. H, okay? If we're talking about the vertex, we're talking about H comma K, right? That's really like an X and a Y. Now, this H is negative B over 2A. Have you seen negative B over 2A before? Yeah, it's the first part of the quadratic formula, right? And then F of H means when you take that output and plug it in as the input of the function itself, you're basically taking input, finding an output, right? So you're going to find what H is and then plug it back into the equation to find output, which would be K. So that's what you're talking about here. Now, you'll look at horizontal shifts and vertical shifts and all that other stuff. Stretch factors there. Parabolas open up if the A, the coefficient of quadratic terms, is greater than 0. We normally say it opens up if A is positive, right? It opens down if A is negative, correct? And then we actually look at it in terms of an absolute value when we start to look at it, if it's stretching, right, or shrinking or compressing. Okay. All right. Um, they've got some given the general conic, general quadratic in general form, find the vertex, blah blah blah. It's this. We'll talk about it. We'll do so many, it ain't funny. Uh, we'll talk about domain and range. Don't worry about all this craziness here with the math. Okay, that's kind of convoluted anyway. Somebody really got happy and started nerding out way too much. They needed to go ahead and take a lunch break at that time. Yeah. Oh, they just filling up dead space. Look how smart I am. Gee. Yeah, they get paid by the page. Let's put our pictures on there. Don't worry about domain and range. We're going to talk about that, and we'll talk about all the other stuff. So let's just kind of get started. Okay, it's talking about x-intercepts, y-intercepts, so we'll just do it. So rewrite the quadratic function in standard form and give the vertex. Basically, take it and put it in vertex form, correct? That's really what they're wanting us to do. So here we go. First things first, we got to find A and our B. So our A is 1, our B is 4. So our H is negative B over 2A. So negative 4 over 2 times 1, which is what? Negative 4 over 2, which is negative 2. That's our H value, right? Okay. Any questions about that? Note that when I substituted the B in, that I kept the negative on the outside and put a parentheses. Because that is your most common mistake that you'll make, is when B is negative, you'll end up just making that negative. One negative and not being a positive. Okay, so we're going to take this negative 2 and we're going to substitute it back into this equation. So negative 2 squared plus 4 times negative 2 plus 7. Ladies and gentlemen, that's 4 minus 8 plus 7. So that is negative 4 plus 7, which is, ladies and gentlemen, 3. So I have an H that is negative 2 and a K, it's okay. Tell me to slow down. It's okay. So I got H is negative 2 and a K that's 3, right? And that's really an ordered pair. Does everybody understand what the vertex is? Yes or no? That is where the transition points happen, right? That's right. It's either your minimum or your maximum, depending upon if it's opening up or opening what? Down. So you got to make sure you're solid on it. Okay. Any questions? No? I'm just going to stretch my legs. Okay. Yeah. It comes from the conic section, yes. Yeah, the parabola, the circle, the hyperbola, and the ellipse all are based upon H and K's. Yeah. And I'm glad that they did use H and K or something other than X and Y, so they'd have to do an X1 and Y1, because it's easier when you're given an H and K, whether it's a parabola or a circle, and you're using a point on the circle itself or a point on the parabola. It's a little bit easier to know where it goes. So a little less confusing, right? Okay, so I hate that they forced a, this is really what this is supposed to be, right? Man, I hate that they've done that because look what's going to happen. Our A, this is our A, right? A is 1. That's the same A of the vertex form, right? So that's a 1. Minus, well, it's negative what? 2, right? I don't like this because we're thinking, okay, that really should be x plus what? 2, right? But what they're trying to get you to understand is when you subtract a negative, it's going to be a what? Positive. And if you remember, when we done vertexes on quadratics, the h value always changed signs when you put it in or took it out of the equation, right? Because of the x minus h. And of course, the k is the external. That's the vertical shift part, right? Then that would be 3. So we'd have negative 2 and what? 3 for a vertex, right? Note that this right here is really going to be what? Right? If you're looking at it from a traditional standpoint, y equals x plus 2 squared plus 3. There's your perfect square trinomial showing up again. Y'all remember that when we completed the square? When you have a binomial written, that's 2 factors are the same as a perfect square trinomial. Okay. Any questions on that? Determine whether there's a minimum or maximum value to each quadratic and find the value of the axis of symmetry. Well, the AOS, okay, is x equals h. It's a vertical line, right? And the vertical line is about the point that is the h value, which is the x value of that vertex, right? That's your folding point. It's like a line of symmetry, right? Axis of symmetry. So what we're going to do is we're going to find the h real quick. But before we do that, is this a minimum or a maximum? What do they mean by that? Which way is it opening? If it's opening up, then you have a minimum. If it's opening down, you have a maximum. Think about valleys and mountains. You'll be okay on that. So this is a positive A, so therefore it's going to be a what? Minimum. That joker's going to open up, and it's going to have a minimum, right? Now, I'm not sure about what they want for the value there. Find the value. Oh, h value, I guess. So h equals negative b over 2a. A equals 2, b equals 4. So the value is negative 1, right? The value of h, that would be what they want by the value. And then the axis of symmetry, x equals negative 1, right? Because x equals a number is the line or the equation for a vertical line. It has one variable. That variable tells you what axis is being crossed, and the number tells you where on that axis. And for these, x equals negative 1 means you'll have a axis symmetry. That's your folding line at negative 1. It should lay smack dab on top of it, right? Yeah? All right. Any questions on that?
Are they actually wanting a point at the minimum, or they just wanting the negative 1?
I think
They wanting
find well, if okay, let's do this. I put negative 1 because I was assuming that they were wanting the h value, right? Okay, so if they're not wanting the h value, then they're wanting the minimum or maximum, which would be a k, right? It'd be a k. So they either want a point or the y equals, right? So let's just go ahead and plug it in, just in case they want it the other way. We've got it covered, right? So that's 1 squared times 2 is what? 2 minus 4 plus 3, so it's negative 2 plus 3, which is 1. So if they're wanting an ordered pair, there you go, negative 1, 1, right? Huh? Oh, 13. That's 11. Right? So negative 1, 11, right? So R, Y equals what? Depends on how they want it. You can either give them to it, I guess, if they say, okay, what the minimum or maximum, its value, then, yeah, that'd make a little bit more sense that they'd want that. Huh? Hmm. I don't know. Maybe they didn't understand that there's only one quadratic function there. You got to think about, are these math people writing these? Probably not, because they're verbally or grammatically correct, right? Think about it. If you got a true analytical mind, you might as well pack it up and go to the house. They're not going to write a. It's going to be a funny book. You know, you have about 80, 85% grammatical correctness there, but you'll run across a done done. I done that, right? Right? Yeah, think about that. Okay, y'all ready? Yeah, give your brains a little bit of time to debrief. All right, so they want you to find the coordinates of the vertex and indicate whether it's the highest point or the lowest point of the graph, and then the axis of symmetry. So what we're going to do is we're going to stop. We're going to give you about a minute head start, and then I'll start and we'll compare, okay? Man, they gave us a fraction, didn't they? Gotta hate that. Man. But if you'll do it by hand, I promise you it won't be quite as bad. So I got 1/2 and 3. Do y'all agree? Yeah? Sweet. Like that. All right. Is it the highest or lowest point? Why are you saying highest? Because the coefficient of the quadratic term is negative, so therefore it's opening down. So that would mean that this is the way it looks like. So that would be a highest. And the axis of symmetry is x equals h. So x equals what? 1/2. How we doing?
Teacher, where does the B come from?
Oh, right here. This is ax squared plus bx plus c, right?
Right.
Yeah, so the b is -4. Or +4, sorry. B is +4. A is -4. Right there.
Which what you plugged it into?
Right here. Because I'm trying to find the vertex. In order to find the vertex, I have to have h. And h is -b over 2a. Right? And once I find that, and it came out to be 1/2,
Yeah.
then I plugged 1/2 in for the x's to, here's an input, find me an output based on that input, right? And then it gave me an output of 3. Yeah, the h equals -b over 2a. That's something I'd make sure I knew. Okay. All right. Any questions on this? Okay. Did I give you enough head start? No questions off these? Me neither. It's okay. No, it's basically the same thing. It's going to take a general form and ask you to put it in standard, which is really vertex, right? So you're going to have to do h equals negative b over 2a. And then substitute it back in. So you're just converting from one form into the other, and then it's asking you a couple of questions. Opening up, opening down, maximum, minimum, highest, lowest, and then what's the axis of symmetry? That's exactly right. It's either mountain or valley, right? X equals h, right? So the h value is 1/2, so x equals 1/2. Okay? I'll just watch it about 16 times. You'll be okay.
That's the highest, because
Well, it's opening which way? Down, because that a is negative, right? All right, determine the domain and range of the following quadratic function in interval notation. Well, first off, guys, the domain for every quadratic that we're going to come into contact with is always going to be this. Negative infinity to positive infinity, period. Okay. The only things that are going to be things that trip you up is, well, it's opening up, it's opening down. So there's a maximum or a minimum, right? So how do we find that? Well, they've given you the vertex form, right? So here's a, here's x minus h squared, and here's k. And if you remember, I said if you pull it out, that the h value has to do what? It has to flip or change signs, right? So that positive 6 has to become a what? And then the k is the number afterwards, and that's negative 7. So the vertex on this is negative 6, negative 7, right? You agree? Now, which way is it opening? Down, right? So the lowest point is who? Negative infinity, right? What's the highest point on the y? Negative 7, is it not? So it's a parentheses, and it'll always have a bracket. You'll have a parentheses for the absolute value, not the absolute value. You have a parentheses for the infinity or negative infinity, period. And then the other number will get a bracket because that is a fixed point, right? And it's included. Any questions on that? How we doing? Right here. How do I get a positive 6 if this is x minus h squared? How do I get the positive 6? Only if the h is what? There you go. So when you pull it out, do what now? It's what they call standard form, right? But it's really vertex, right? We all know it by vertex. Let's just call it what we all, but they're going to revert to it as standard. And then general is normally what we'd call standard, which is ax squared plus bx plus c. But they call it general, right? Yeah. It's like what came first, the chicken or the egg, right? Chicken. Egg can't survive. It has to be incubated. Think about it. Ma'am? The points for attempting. Only if the attempted part's correct. Yeah. Only if the attempted part's correct. Sorry. Just remember, when in doubt, do what? Pray. Good. Yeah. If there's one thing that's going to change in here, your prayer life is, right? Sorry. Like, whoo, divine intervention. Well, it's never too late. So, I moved that comma down so that it didn't look like it was negative infinity and negative infinity, right? So, okay. Let's do another. I had that comma way too far up, so it could appear like it was negative infinity and negative infinity. So I erased it, moved it down, so it was in the right location. Okay, guys. Determine the domain and range of the following quadratic function in the interval notation. All right. Domain. That's like a rubber stamp. Ching ching. Okay? You got to make sure you understand that. There. Now, what are we going to do? Which way is it opening? Let's just talk about that. It's opening up, right? So, man, I know that right there is so, right? Y'all see that? I know the highest point. If it's opening up, baby, the highest point is infinity, right? So how am I going to figure out what's the lowest point? What would the lowest point be called? Your vertex, right? Which is an h and a what? So what's your h value? Negative b over what? Now, how do I remember these equations? Every time I work them, I write them down. It takes 2 seconds to do it, but the payoff and the dividends in your brain is tremendous. Here's your A, here's your B, here's your C. So we have minus 12 over 2 times 3, so that's negative 12 over 6, which is negative what? 2. So that's going to give me 3 times negative 2 squared plus 12 times negative 2 plus 13, now that I can see and count. So that's negative 2 squared is 4. 3 times 4 is 12. Minus 24. Y'all see a pattern there? Did you notice that the first one and the second one, the first is always half of the second one, and the second one's opposite sign? Have you noticed that? Really? Yeah, there's a pattern there. There is. Just be mindful of that. So if you don't get these right here to be half of one another, one positive, one negative, you've probably done something wrong. I got 1. So that's really, this joker's opening up, right? Right there. So that's negative 2, 1, right? Which would be what here? Right? And if you look back at it's saying K, right? It's saying K, comma, infinity, right? Y'all, if you look back on your notes, it'll tell you that back on the first couple of pages, right? Yeah. So forth. It will. But if you draw this right here, you'll be okay. Questions? Y'all good? Okay. Let's go green. Well, then went green. Let's go blue. Graph the parabola. Do not place any dots, then fill in the blanks about the vertex and the x-intercepts. Graph the parabola. Do not place any dots. Are y'all reading what I'm reading? How are we going to graph it if we don't put any dots? Lord help them.
You can erase right there.
Off your computer screen?
You
No. You can. Just you got a surface. So, anyway. Then fill in the blanks about the vertex and okay, so guys, it's 2x plus 1 squared plus 1. So guys, it's ax minus h squared plus k, right? So if we're going to graph this, it's h comma what? H comma k. So what's my h? How do I get a positive one? It has to be a what? Thank you. K is exactly what's there. Right? How we doing? So negative 1, 1. Which way is this joker opening up? Up. Your A is 2. It's positive, right? 2 just means it's going to be a little narrow, right? A little skinnier. It's going to be a stretch instead of a shrink. And then it's positive, and it's going to open up. So kind of look at this. How are we going to then fill in the blanks about the vertex and the any intercepts? Oh my. Guys, I'm going to teach y'all something. The first change of any vertex, or not vertex, parabola, is should be the A. And that's 2 over 1, right? So up 2 over 1, up 2 over what? Now, I'm going to graph this thing. Y'all know I am, right? I'm about to graph it. Just to prove, if you've done a lot of theory with quadratics, that should hold true there. If you've looked at the income rate of change and filling out stuff. Don't.
Sorry, it says negative 2 over 1, or just negative 2 and just 2 over 1?
2 over 1. Yeah, 2 over 1. Up 2 over what? Huh? That's A. A is the first rate of change. Should be. If it's in standard form, which is really ax squared plus bx plus c, that's true. Should hold true for the vertex form. But we're going to validate that. You ready? Yeah? Okay. Man, I love my graphing calculator. Sorry, I just like to nerd out. Okay, here we go. So what is the problem? 2x plus 1 plus 1, right? 2. So y equals, let me get the clear. 2x plus 1 squared plus what? Better get on up in there. Plus 1. Yeah? All right, so let's graph it. Hey, look at that. Then let's just zoom 6. That's zoom fit, right? There you go. So you can't really tell a lot from that, but you can if you look at a table, right? So I like tables. You like tables? I like tables. Here we go. So we're going to delete those, and let's see. We said it was what, negative 1, right? So let's put negative 2, enter, negative 1, enter, and 0, enter. Ladies and gentlemen, it should be up at 3 and 1 and 3, right? Y'all agree? Yay or nay? Okay, good. Let's go back and look at our graph. Hey, that's exactly what we got, right? So yeah, the A does follow suit on the vertex form as well. Y'all did know that A was always the first rate of change, right? No? Really? Man. That's pretty cool. Okay. You good? Do we got to answer anything down here? Yeah, what's vertex? Yeah, we got to do that. Negative 1, 1, and that's 0, what? 3, right? Yeah. Now, how do you find the y-intercept if they are, you draw a blank, right? Well, how do you find it? Well, let's look. Y equals 2 times 0 plus 1 squared plus 1, right? Because when I want the y-intercept, x is what? That's right. So that's 2 times 1 squared, which is what? 1, and 1 times 2, so that's 2 plus 1, which is what? That's 3, right? All right. Any questions? So you can always do that. That's always a go-to right here. Yeah? No? Oh, I don't know. How you gonna place dots and graph something if you don't place dots? I don't know. Okay. Next. Find the vertex and a convenient point. A convenient point. Sketch the graph of the following. What's convenient, right? Now my question is this: y equals x squared minus 3. What form is that in? Which form is it in? You don't know? No? Well, there's not but 2 forms to choose from, right? You agree? Hey, yeah, that's quadratic. But which form of a quadratic? Yeah. Oh, which form? Come on. We said standard or what? General, right? So let's kind of back it up to a terminology that we have been using, right? Vertex form, or is it in standard ax squared plus bx plus c, which they're calling general, right? Which one is it? Looks like a vertex form, doesn't it? Ladies and gentlemen, it's actually in both forms. When you have no linear term, you have both forms represented. Because here you go. If I wanted to write this in vertex form, what's this? It's already there, but I want you to think about this. Right? What does 0 do to it? Not a dab blame thing. Right? It changes nothing. 0, 0, right? And then if you look at it like this, well, I will tell you this. And it's only like this when the h value is 0. It's only like this when the h value is 0. You know what this number right here is? Anybody know what that number is? The what? That's exactly correct. And we didn't shift this left to right, so it just went straight down, right? And the slope on that A is 1 over 1, right? So over 1, up 1, right? Or up 1, over 1. So there you go. That's your 3 dots, right? Correct? A is 1. So that's really 1 over 1, which is changing y over changing what? X, right? Okay. Find the vertex. We found it. It's 0 what? 0 negative what? 3, right? Because the h value is 0 and the k value is negative 3. And then convenient point would be, okay, it's just taking a parent function, moving it down what? 3 units, right? Y'all remember shifting? Shift happens. So just remember that. Y'all good? Uh-oh. Guess what I skipped? That I shouldn't skip. 7 point what? Yeah, 7.1 is supposed to come before this. It's okay. Yeah, it's different. 7.1 is linear. It's okay. It's just some stuff. We'll go back and hit it. It'll be okay. I promise. Huh? Oh, but they looked at it and they put linear and then put quadratic in there, right? I should have done 7-1 then 5-2. 5-2 is the last thing.
Oh, well,
And yeah, 5-1. Sorry, not 5-2. My bad.
it's silly you were going nowhere order.
Well, I thought it was open, but it's okay.
That lot of people.
Listen, all we got to do is do elimination, substitution, systems. That's all that 7-1 is systems of linear. That's all it is. So, anyway. Okay. Man. All right. We'll get there anyway. Here we go. Use the vertex h comma k and a point xy to find the standard form of the equation of this quadratic. Guys, what are we actually solving for here when we put in all this? Huh? What's the one thing that they didn't give us? The a, right? Think about it. They gave us an h and k and an x and a what? That's exactly right. So the only thing that they did not give us was a, right? Y'all see that? Yay or nay? Yeah, come on. I'm going to plug it in, right? So here's my x and my what? And there's my h and my k. So -2 equals a. -2 minus minus becomes what? Plus, right? 3 squared. And the k is plus 0. So that's -2 equals a. Well, that's what? What is that? 1 squared plus 0? So that's really -2 equal to what? A. So that would be -2 x plus 3 squared. Do I have to put the plus 0? Nah. There you go. Yeah, this is a pretty traditional one right here. They're giving you h and a k and x and a y and tell you to find a. Right? Sometimes they say here's your vertex and a point on the parabola. Write the equation. That's traditionally what they do. So. Questions? Anybody? All right, let's get into some word problems. The most famous word problems that you could ever do for a quadratic is this: projectiles. Okay? You're going to shoot something. You're going to use a quadratic equation. I don't care what it is. All right? Anybody study ballistics of things? Paths of bullets and whatnot? Like that, right? It goes up. Yeah. All right, bullets. And then when you're sitting on a boat way off in a sea and you shoot it something that way, it goes up and then it goes what? Down. It's a parabola. It's quadratic. So they're doing the math behind it. Huh?
I just throwing an R.
Do you know what that a sniper does trig in his head in a matter of seconds? Yeah. I couldn't hit the broadside of a barn. No.
I pegged you as someone who's a pretty good shot.
I am. But I couldn't hit the broadside of a barn not way off. Couldn't see it. No, can't see it. Got that shakes. Yeah, that's not good neither. Right. Yeah, you got to be still, right? Breathing, all that stuff. I love to watch them. Huh? Yeah, it's exhaling, right? It's on the exhale of your breath. So everything's out, right? Yeah, yeah, yeah. All right. The height of an object tossed upward with an initial velocity of 64 feet per second is given by the equation negative 16 t squared plus 64t, where h is the height in feet and t is the time in seconds. Find the time required for the object to return to the point of departure, meaning find its time that it takes to hit the ground. Okay, in theory, the time it takes to go up equals the time it takes to go what? Down, right? Does that make sense? So there's two ways to think about this, because you can all right, so, right, there's ground. Ground. Yeah, go ahead and make fun of me. It was, but it's okay. All right, so that sucker's going up, coming back down, right? So all you're doing is negative 16t squared plus 64t equals to what? 0. What's its output? When do you want to know its output? That's 0. Folks, I have a quadratic term and a linear. Anybody want to know? Take a jab or stab or guess how we're going to solve this? Y'all remember? Oh my gosh, Lord, yes. Be still my heart. Factoring, GCF, right? No, not factoring like factoring GCF, right? You meant GCF, right? Factoring GCF. Yeah, I know you did. I know. I just have a feeling. All right. So when you factor out GCF, you either factor in a number, a variable, or the product of a number and variable, right? Well, both these got variables, so we can at least do that, right? So can I factor out something at a number? So I'm going to factor out a negative 16t. That's going to leave me with t minus what? 4. T minus 4. So we actually have two factors here. Most people go, that's just that times that. No, it's two factors. So you take each factor equal to what? That's right. So that one is automatically what? Hey, that's when it started, right? And then, ladies and gentlemen, when did it return down to the ground? Now, my next question would be this. How long did it take to get to the top? Yeah, so how long would it take to get to the top? No, 2. 2 going up and 2 going down for a total time of what? 4, right?
If you're acting against the gravity, in theory, yes, it takes the same amount of time.
Would the acting against and the going with cancel out?
Not necessarily. Depends on how hard you throw it.
Well, that initial velocity is 64 feet per second.
What is gravity? 9.8 meters per second squared?
If it's in metric, 32 feet per second square if it's in what? Standard units, right? Yeah, 32 feet per second squared. Yeah, for sure. Because that's how they get negative 16. They go negative 1/2 g, the gravitational constant, right? Yeah, no, that's a positive, trust me. I have done more than I ever want to know about these equations. Okay, so just in theory, just understand, theory, that from here to here is 4. So it's 2 seconds to get to here, and then 2 seconds to get to where? Down there, right? That's only because it started where, folks? On the ground. On the ground. Now, if it started somewhere else, then that can't be true. You understand? Because if 100 feet up in the air, it takes less time for it to get to the maximum on that, right? So, yeah.
Like when it hits this far up, it's going to go up.
Vertex.
That is vertex?
Mhm.
Okay.
Yeah, up here. Yeah, I don't
Are
know.
they synonymous?
I don't know.
Yeah, in this case, probably.
Would it be Dayfats?
I don't think so.
Yeah,
Yeah.
yeah. Carter's shaking his head. Yeah. So 3 out of 3 say good,
Let's start getting inside.
or 4 out of 3 were okay with that. So. All right, y'all ready? Hey, y'all should really go back and listen to some of these videos. Yeah, you never get anybody like this right here again. I promise. Ever. Ain't it though? Lord help us. Uh-huh. Sure enough. All right. I put this on here just because I wanted a challenge.
Will this be one of our questions?
Is it one of we doing on the homework? Yeah. Yeah. These come straight from homework, right? Yeah, straight from it. Now your numbers will be different, right? But the approach or process will be the same.
I mean, your keyword was challenge.
Well, why do I say that this is a challenging problem, guys?
Because it worked.
Because them numbers ain't pretty. Them things ain't pretty. They ain't. And we're going to do it anyway. So a company finds that it can make a profit, P dollars, each month by selling X patterns. According to the formula, P of X equals negative 0.002 X squared plus 5.5X minus 700. How many patterns must it sell each month to have a maximum profit? To obtain maximum profit, they must sell blank patterns. And what is the maximum profit? Well, X is the number of patterns, right? The Y is the who? Profit, right? Now, I'm using X and Y. That's really what? Well, it's really going to be my H and my what? K, right? Because they want to know what's my highest, right? Maximum. That baby's got to open down, right? Hey, it's opening down. It's got a negative 0.002. So here we go. A, well, I don't want that. Whop it, y'all. A equals negative. Yeah. So I don't know what that is. So that's negative 5.5 divided by 2 times negative 0.002. Ooh wee. I got an H value of 1,375. Did you? Don't sure me. Girl, you got to know this. You got to know that you know you know. You know? So how many patterns are we selling? 1,375. Now that makes a little bit more sense, right? I mean, it's crazy numbers, but they come out pretty in the end. Now we got to take this right here, and we got to go, oh my. And we got to plug that 1375 in, right? Yeah, if we had this in mathematical modeling, we'd have it done lick because we do it on calculator. All of it, right? It was wonderful. So let's do it. Negative 0.002, parentheses, 1375, right? Squared, plus 5.5 times 1375. Make sure I typed in things in right. Negative minus 700. Shaboom. I have a K value, ladies and gentlemen, of $3,081.25. How do we do? Somebody please tell me they got the same as me. Y'all good? Huh? We got one more problem. That's it? On this? I gotta slow down. Not really. How we doing? Y'all agree? Got a couple head nods. Yeah. Okay. All right. If you watch this video, make sure you understand we done 5.1 before we done 7.1, so it's out of order. Just be aware of that. All right. Solve the problem by writing and solving inequality. A rocket's fired from the ground level. Its height in feet t seconds after launch is given by 320 t minus 16 t squared. During what time interval is the rocket higher than 1024? Nope. Nope. Ladies and gentlemen. Can I do this? Are y'all okay with that? So you want to see how long it takes to get there, right? That's an output, right? 1024 would be, that's an output. That'd be like doing a horizontal line at that point, right? Do y'all agree? What? Yeah.
1024 is not higher than 1024. It's 1024.
Uh-huh. But look at those inequalities. Those aren't equal to, are they? Okay. So if it's higher at 2 and 5, if I put 2 and 5 there, I'm good. If it's 1024 at 2 and 5, I'm good. Because it's not equal to. It's greater than and less than, right? It's not greater than equal to or less than equal to. So therefore, if I put those designated points, I'm good, right? So if I set this equation to that output, and output's 1024, right? And I solve this crazy quadratic, which, how are we going to solve this crazy quadratic? How y'all want to do this? Will 16 going to 320? Yeah, sure will. We're going.
If you also just move 1024 over.
We are. Anytime you go to solve a quadratic, you got to make sure that it's what? Yeah, exactly. Good job. Equal to 0. So I'm going to take this over here. And then I'm going to do this. See if y'all agree with this. So if I divide everything by negative 16, guys, I get t squared. Uh-oh. My calculator said something about memory. Minus 20 plus 64. That's minus 20t, right? Equals 0. What are factors of 64 when added together give you 20? How much? Look at you. That's awesome. So negative 4, negative what? 16, right? Because those add together to give you negative 20, but they multiply to give you positive 64, right? So t minus 4 equal to 0. T minus 16 equal to 0. So t equals 4 and t equals what? 16. So it has to be greater than 4, but less than what? That's right. That's when it will cross 1024. It'll be higher than at 4 and 16. Now, we shot this from the ground, right? Right. So what's the spread between 4 and 16? 12. So if I went, that's 6, right? The highest point, the x value is 10. How did I do that? They shot this from where? 0, right? From the ground, right? So there's symmetry, right? correct? 4 and 16 gave me an output of 1024, right? So what's the distance between 4 and 16? It's an overall of 12. What's half of 12? 6. So if I go 6 in, I'm on the vertex right there. That's the x value, or h of the vertex, right? That would be 12. 12 seconds to get to the top. Yeah, don't take my word for it. Okay, listen up. Your brain is mushed. Okay, so we're going to stop right there. But we're going to talk about stuff. We got to talk about some stuff.